Okay, so today we're going to dive into a government document that, let's be honest, looks kind of dry. But trust me, it's actually a fascinating window into this hidden world of software, a world with no buttons, no screens. It's a look at how incredibly complex systems are run with just absolute, non-negotiable precision. So, what you're looking at here is the Software Input/Output Manual, or SIOM for short. Now, this is a user guide, but it's not for an app on your phone. Nope. This is for software you literally can't see or touch, stuff that's tucked away deep inside a computer center. And this manual, it's the only way for specialists to talk to it, to give it commands, and, just as important, to actually understand what it says back. Right, so that's the big question, isn't it? If you can't click on anything, if there's no screen, how in the world do you use this kind of software? What does a manual for that even look like? Well, let's break it down. All right, here's our game plan. We're going to start by seeing how a CIOM is totally different from a normal user manual. Then we'll walk through how it sets up the system, how users put their instructions in and get results out, and finally, we'll get into why this insane level of detail is so important. Okay, first up, you've got to understand this is not your average instruction booklet. This is a highly specialized tool for a world that existed long before the mouse and the graphical user interface took over. So the official definition really gets to the heart of it. A SIOM is for software that's run in batch mode. Think of it like this. You write out a super long, super specific to-do list, you hand it over to someone, and then you come back hours later to see the results. There's no changing your mind halfway through. It's not a conversation like we have with our apps today. And this slide just nails the difference, right? A regular user manual is all about what button to click, what menu to open. A SIOM is about following a strict, rigid set of rules to prepare a job, hand it off, and then decode the report you get back. You're not really using the software yourself. You're telling an operator exactly how to run a job for you. So where do you even begin with something like this? Well, before an operator can submit a single command, they need a ton of context. The manual's first job is to basically give them a complete system briefing. And just look at how thorough this is. The manual covers everything from the software's basic purpose to the exact hardware it needs to run on. It even inventories every single file needed for an emergency restoration. This isn't just some light background reading. This is absolutely critical operational knowledge. Okay, now we're getting to the good stuff. How do you actually tell the software what to do? You have to speak its language, and the SIOM is basically the dictionary and the grammar guide all rolled into one. Now, this is nothing like typing a search into Google. Every single input is a highly structured, almost ritualistic process. You have to follow an exact layout, obey strict rules for every comma and period, and use only a pre-approved vocabulary. You mess up one character, just one, and the entire job could fail. And here is what that looks like in practice. Wow! This is the format for just one kind of query. See that? Character position 1 must be a Q, positions 2 and 3 must be 0, 1. There is zero room for error. Every single space on the line is defined and has a purpose. That's precision on a whole other level. So you've carefully prepared your input, you've submitted it, and the machine has done its job. Great. Now, how do you make any sense of what it gives you back? Well, the output is just as structured as the input. The manual provides a key, like the table you see here, that tells you exactly how to read the data. It'll say, okay, the organization name will be 30 alphanumeric characters. Gross pay will be 6 numeric characters, and it's measured in dollars. It's the Rosetta Stone for understanding the machine. And the level of detail is just staggering. The SIOM defines everything: headers, security markings, what special symbols mean. The whole point is to eliminate any and all ambiguity. When an operator gets a report, they need to know with 100% certainty what every single character on that page means. But the manual doesn't just cover simple data in, data out. It also gives operators the tools to ask really specific questions, and, maybe most importantly, how to handle things when they go wrong. I mean, getting a massive report is one thing, but what if you just need one specific piece of information from it? You can't just browse through it, you have to ask a perfectly formed question. And to make this a little easier, the SIOM provides a list of pre-programmed query codes. You can think of them as shortcuts. So instead of writing some complex command to calculate the total gross pay, the operator can just use query code C. It's a super efficient way to get common answers fast. And here we go. This is a full query statement in the wild. If org ID equals OSD, list no of employees. It almost looks like an English sentence, but every single part of it, the if, the EQ for equals, is a rigidly defined piece of that machine language. This is how you ask a very, very specific question. But what happens when the machine spits back arrow 504? I mean, without a guide, you'd be totally lost. The SIOM includes this huge list of every possible error code, what it means, and the exact step-by-step procedure to fix it. This is absolutely critical for keeping the whole system from crashing. Okay, so let's zoom out. We've seen the incredible detail, the rigid structure. Why go to all this trouble? Why does any of this matter so much? This quote from the standard itself really grounds us in what we're talking about. These are massive, centralized, high-stakes systems. They could be managing military logistics or payroll for tens of thousands of people or other critical infrastructure. You just can't afford to have mistakes. So ultimately, the software input/output manual is all about creating certainty. It provides crystal clarity to avoid any confusion. It standardizes everything so any trained operator can step in and run the system. It ensures safety with clear emergency plans, and it guarantees repeatability, which is the absolute bedrock of any reliable, large-scale system. It really makes you think, doesn't it? In our world of user-friendly interfaces and AI that tries to guess what we want, there is such a powerful lesson here about the value of precise, unambiguous communication. It leaves us with a pretty interesting question. What do we lose when we trade rigid procedure for convenient intuition?